Hey guys, today we're going to learn about prime factorization and greatest common factor. We're first going to start with section 2.6. Again, that's from the textbook if you need to look up anything, but it's going to cover prime factorization. So first we're going to start off with just a few definitions. A prime number is a number that has exactly two factors, okay, one and itself. So again, prime number, a number that has two factors, one in itself. Now, just to quickly explain what a factor is, so if you have the number 10, factors are numbers that can be multiplied together to get the value of 10. So factors of 10 would be 5 and 2. Other factors of 10 would be 10 and 1. Okay, so that's what a factor is. Now, a composite number is a number that has more than two factors. So again, number that has more than two whole number factors. Keep in mind that both of these, I want to say this, is that the number 1 is not a prime number, and it's also not a composite number. Composite numbers has to be a number greater than 1. All right, so we talked about prime and composites earlier today when we played the game Buzz. So I'm going to circle, it says circle the primes and put a box around the composites. 7 is prime because obviously the only factors of 7 are 1 and itself. Okay? 18, it's a composite number. Okay? It has more than two whole number factors. 51 is composite. Again, has more than two whole number factors. 47 is prime. The only factors of 47 are 1 in itself. 39 is composite, 23 is prime, and 17 is prime. Now, prime factorization helps us, especially when we start getting into greatest common factor in LCM. So let's practice prime factorization. Prime factorization is just breaking a number down into its prime factors, and I'll explain what that means here in a second. But we use what we call a factor tree. All right, a factor tree is very simple. You just start breaking the number down with its factors. You can pick any numbers. Okay, I'll do it in fact two ways. So what you do is you start making the tree branches and you start breaking them down. You ask yourself, well, what two numbers multiply to 36? Again, you can pick any two. All right, so typically a lot of people say 6 and 6 on this one. Now, what you do is you circle any number that you write down that's prime. Now, 6 is not prime, and the other 6 is obviously not prime. So what you do, you ask yourself, can I break down the 6's anymore into their factors? Well, what are factors of 6? 2 and 3. I could do the same thing over here with 2 and 3. Now what you notice is, again, I just wrote down 4 prime numbers. The 2, the 3, the 2, and the 3. So I broke down this 36 into its prime factors. And if you notice, these are the prime factors. And if you look, 2 times 3 is 6, times 2 is 12, times 3 is 36. So again, 2 times 3 times 2 times 3 is going to give me 36. We just broke it down into its prime factors. Now if I did it again and did 36 and I chose different factors, for example 9 and 4, okay, those are good factors of 36. Now ask yourself, are either of those prime? If they're prime, you'll circle them. If they're not, you'll keep breaking them down. Can I break down 9? Yes. 3 and 3. Can I break down 4? Yes. 2 and 2. Now I can circle that 3, that 3, that 2, and that 2, because those are all now prime numbers, because 3 and 2 are both prime. And if you notice, again, 3 times 3 is 9, times 2 is 18, times 2 is 36. So I just broke it down into its prime factors. Now, let's try the next one, 490. If I broke down 490, I'd probably pick 49 and 10 as its factors. Now, neither of those are prime, so I'll break them down even more. 49 is 7 and 7. Both of those are prime, so I'll circle it. 10, break it down with 5 and 2. Both of those are prime, so I'll circle it. So again, if I were to do this math, if I multiplied all 4 of these numbers together, it would equal this 490. Now, you notice here on this slide, it says, what's the biggest pitfall of factor trees? This is, by far, leaving a composite number in the number tree. So you really have to know your prime numbers. Okay, so especially 1 through 100. I have a lot of people that they think it's prime and they circle it. And when it's really, it can be broken down more. So let's just try 2 more. Let's try 56. Let's bring 56. I'm going to go 8 and 7. 7's prime, so I can circle it. Break down 8 with 4 and 2. That 2 is prime, so I can circle it. Break down 4, 2 and 2. Both of those are circled. So again, 2 times 2 times 2 times 7 would equal 56. So I just broke down 56 into its prime factors. Let's try one more. I'm going to move this one over here for a little room. 960. Again, I'd probably go 96 and 10, because that's easy. Breakdown. 10 with 2 and 5. Both of those are prime. Started off with the easier one that time. Now, 96. Now, this one may take you just a little bit, but I just think of another important thing is think of divisibility rules. It's an even number. I can divide it by 2. That's always the easiest one to do. So if I divided that by 2, that would be 48 and 2. 2 would be prime, so I can circle it. Now, 48, I can break that down more. I'm going to go 6 and 8. Neither of those are prime. Break down 6 with 2 and 3. Circle those because both of those are prime. 8, 2 and 4. 4 can be broken down with 2 and 2. So this one's a long one, but if I did, I'm going to write this one out. 2 times 3 times 2 times 2 times 2 times 2 times 2 times 5. Okay? If I multiplied all of the prime factors of 960, I would get, obviously, 960. So this multiplied all together are the prime factors of the 960. So like I mentioned earlier, the reason we do prime factorization is because it really helps us when we're trying to determine what the greatest common factor is. The greatest common factor of numbers are the largest common factor of 2 or more given numbers. So, I'll give you an example. Okay, if I have 10 and 8, the largest factor that can go in these, all right, would be 2. Okay, 2 goes into 10 5 times, 2 goes into 8 4 times. But 2 is the largest factor, okay, number that can be multiplied to get 10 or 8. Or another way you can say it is, what's the largest number that both of these numbers can be divided by? So the example above kind of explains why we use GCF. One of the big reasons we use GCF is to reduce fractions. It helps us reduce fractions. Again, if I had, I'm going to use this example. I like my example a little bit better, so I'm going to change it to this. But in order to reduce that fraction, I ask myself, all right, what is the GCF between 16 and 24? Or again, the highest number that can be divided by both of those. So, 16. Okay, yes, they both can be divided by 2, right? But is that the greatest common factor of 16 and 24? Again, the greatest common factor in this case would be 8. Okay, so the greatest common factor in this case would be 8. So if I took 16 and I divided it by 8, you would get 2. Okay, and if I took 24 and divided it by 8, you would get 3. And so again, knowing the GCF helps us reduce fractions. I'm going to start off easy on how to find GCF, but we're going to use factor trees, and this is the method that I want you to use on this. Now, sometimes this is easy, so some people can do it in their head, but just follow this method. I'm going to make a factor tree for both of these. If I broke down 30, I'd go 3 and 10. 3 is prime, so I'd circle it. I'd go 2 and 5 for 10, both of those are prime, 2 and 5. 42, again, if you don't know, you can divide it by 2, 2 and 21. And then 21 can be broken down 7 and 3. Now, for the GCF, here's what I do. This is my method. I cross out the ones that they both share. So, for example, they both have a 3. So I cross both of them out. I write the number 3 down here by GCF. Do they share anything else? Yes, they both share 2. I cross those out. I write it down there. Now, the numbers that are written for the GCF, that I pulled out that are the shared factors in the factor tree, I now will multiply them. So 3 times 2 is 6. 6 would be the GCF for 42 and 30. So again, 6 goes into 35 times, 6 goes into 42 7 times. That's the greatest common factor. Let's try another one, 36 and 60. Again, use a factor tree to break it down. 6 and 6, 2 and 3. I'm going to speed up just a little bit. 2 and 3. Okay, I broke it down into its prime factors. That's what we want. 6 and 10, 2 and 3, it's prime. 2 and 5. Now again, write down GCF. Now let's start writing down the shared prime factors. Do they share a 2? Yes. So they both share 2. Write it down. Do they share a 3? Yes. Write it down. Do they share another 2? Yes. Write it down. Do they share anything else? The answer would be no. So in this case, I'd take 2 and multiply it by 3 and then multiply that by 2. So 2 times 3 is 6. 6 times 2 is 12. So the GCF in this case is 12. That's the largest factor of 36 and 60. All right, I'm going to try one more, but I'm going to throw a third one in there. Okay, I'm just going to say 165. I'm going to make this one kind of hard. So here we go. 8 and 10. Break them down into its factors. 4 and 2. 2 and 2. Circle it. 2 and 5. I've now broken 80 into its prime factors. Still 120. Let's go 12 and 10. Let's go 2 and 6. 2 and 3. Again, it doesn't matter what order you do it in as well. 2 and 5. That's prime. Let's go 165. So 165, I'm going to go 16. I'm sorry, not 16. The easy way to remember this one is, if you have a 5 in the end, if you know your divisibility rules, it's divisible by 5. So I'm definitely going to do that. Now, what you're going to find is, I'm going to erase this, is that it's going to be 33 and 5. Now, 5 is prime. Now I can break down 33 with 11 and 3. And both of those are prime. So, kind of a random one. Now, the GCF between these 3 numbers, again, they have to be shared now by all 3 of them. So, let's see. Do they all share a 2? Okay? Well, 80 and 120 both share a 2. But 165 does not. So 2 is not. Let's try, they have a 5 in each of them. Okay, well this one has a 5, this one has a 5, and this one has a 5. So I'm going to write down 5. Do they all share a 3? 80 does not share a 3. This has a 3, that has a 3, but again, since 80 does not, they don't share it. All 3 of them do not share it. So the only prime factor that they all share is a 5. So the greatest common factor of 80, 120, and 165 is 5. So to make sure you are watching the videos, this is something random that I'm going to make you do. So I'm going to have you do the factor trees of 36 and let's say 400. Okay? So what I'm going to have you do is you're going to do factor trees and you're going to draw me a picture. And in the picture, okay, you're going to do the factors. You're going to go 6, 6, okay, 2 and 3, okay, and I've got my tree. And then I'll let you go ahead and do 400 on your own. But I want you to decorate and draw a picture and make these like Christmas trees, okay? Or any kind of, you can make anything. Draw me a picture with these factor trees, okay? Break it down into its prime factors and draw me any pictures with those being trees. Again, completely random, but making sure you're watching. Y'all have a good weekend.